This is the 3.2 day 2 notes. We were talking about identifying things as linear or nonlinear in our function unit on day 1, and today we're kind of extending that and then also talking about discrete and continuous data. Okay, so in order to be considered to be discrete data, what you're looking at is input values that consist of only certain numbers in an interval. So those are going to look like individual data points. More than likely, they're whole number data points, but they don't have to be. So like discrete data would be graphed with dots that are not connected by a smooth curve or line. Then continuous data is a set of input values that consists of all the numbers in an interval. So it's going to be graphed with 2 points that are going to be connected by a smooth line or curve. And those are going to be things that include parts like decimals or fractions, something where parts would make sense. Okay, so we kind of went from this information to talk about domain and range through our lesson today. So you should have your notes out, and we're going to go ahead and get started. Okay, so let's look at this scenario that we have here. It says the linear function m equals 50 minus 9d represents the amount m in dollars of money you have after buying d DVDs. They've asked us to find the domain of the function and determine whether it's discrete or continuous, and then we're supposed to explain. So let's kind of talk about the scenario to start with. So they're telling us that we have $50 and we are spending $9 for every DVD that we buy. So if you think about that, M being the amount of money that you have left, you can't go past $0. I mean, you can spend all of your money or you can spend some of it, but you can't spend more than you have. So if we're trying to find our domain, then what they're really asking us is how many DVDs can we possibly buy for that $50 amount that we have. So what I'm going to do is I'm going to set my equation equal to 0 because that would be if I was to spend all of the money, and I'm going to solve. So the first thing that I would do to solve this equation is to subtract 50 from both sides. When I do that, I get negative 50 is equal to negative 9d. The opposite of multiplying by negative 9 would be to divide by negative 9, so those would cancel. And then when I actually do that division of negative 50 divided by negative 9, I get 5.5 repeating. Okay, so let's talk about that for a minute. So D was supposed to represent the number of DVDs that we purchased. So you can't purchase 5.5 repeating DVDs. So for this particular situation, since we're supposed to be finding the domain, and don't forget your domain is your set of all the x values that would make sense. So our domain in this case, we know that we could buy 0 DVDs, we could buy 1 DVD, 2 DVDs, 3 DVDs, 4 DVDs, or 5 DVDs. Since my answer here was 5.5 repeating, I know that I have enough money to buy up to 5, but I don't quite have enough to buy 6, which should make sense to you because if they're $9 each, 9 times 6 is 54, and we only have $50. Okay? So notice that I'm listing out my numbers as individual data. I have 0 DVDs, 1, 2, 3, 4, 5. I don't have parts in there. Therefore, for the part of the question that asks if the domain is discrete or continuous, it would be discrete. And then for your explanation, you can't buy part of a DVD. Or you could say something about the fact that only whole numbers would make sense. Okay? Alright, this is how we list our domain. We use the little brackets and then we list the individual data points. We talked about that on day 1. Okay? Alright, so then it asks me to find the range of the function. So what I'm going to do at this point is I'm going to make a little t-chart. So I already know my domain values are 0, 1, 2, 3, 4, and 5. So to find the range, which remember your range is y, there's a couple of ways that I could do this. I could substitute these values that I just found, the 0 through 5, into the equation that they gave me. M, your amount of money, would be your range. Or we could do like I showed you guys, and we could put it into our calculator. So I'm going under y equals, and I'm putting in 50 minus 9x. Now notice in the equation that they gave me, they used d to represent my independent variable, but I'm going to use x in my calculator. Then I press second and table, and then I can look at my table and just fill in my range. So I know that if I don't buy any DVDs, it's going to cost, I'll have $50. 1, I would have 41. 2 is 32. 3 is 23. 4 is 14. And 5 is 5. Okay? So if they're asking me to find the range, I'm going to go ahead and write that in our set notation. So I'm going to do a bracket, and then I'm going to list the values, separating them by commas. So all I'm doing is taking the information that was in my table, and I am writing it in my brackets, 23, 14, and 5. Okay? Alright, so the last thing that it asks us to do is to graph the function using its domain. Now, when we did this in class, remember we talked about what an appropriate scale would be, and we decided to go by 1s on our x, and we decided to go by 5s on our y, and kind of, estimate where that would be. And when we graphed this, it came out to be linear. So it would be difficult for me to graph here. I don't have a stylus with me tonight, but when we graph, we know that our graph is going to start at 0, 50. So let's just say that would be this point right here. And every time that I purchase a DVD, the amount goes down. So this would wind up being a linear function because my data points would slope in a downward motion. Okay, so if I was to graph, it would be something like this if I had my scale on there for you guys. Okay, and they would be individual data points. Alright, so let's go ahead and look at the next one. So for the next example, what I've done here is I've given you a table of values, and I'm asking if the domain is discrete or continuous. So remember, domain is your input or your set of x values. So in this particular table of values, what we have is, it says that we have the number of stories as my input, and the output is the height of the building in feet. So if you think about the scenario, ask yourself, would parts make sense here? If we're talking about number of stories, do you ever go to the 1.5 story, or are those counted in whole numbers, like 1, 2, and 3? So obviously these are counted in whole numbers, therefore this would be discrete data. For your explanation, you could say something to the effect of that, number of stories would be whole numbers only, or you could say that those would be individual data points. It would be parts of an interval, not all of an interval. Any of those things would work. Okay, so our last problem is similar to the one that we just did with the scenario where they give you a word problem. You have to determine the domain and range and graph. So what I'd like for you to do now is pause the video and see if you can do this one on your own. Then start it and check your work with mine. Okay, so this problem was a little bit different than our last one that we did that was a word problem because you had to come up with your own equation. But they gave you all the information that you needed right here. So we know that we have a 20-gallon bathtub that's draining at a rate of 2.5 gallons per minute. They tell you that the number of gallons remaining is a function of the number m of minutes. So that was supposed to help you identify your independent and dependent variable. So if g is a function of m, then we know that g, the number of gallons left in the tub, would be our y value, or our dependent variable, which we use to find our range. Okay, so when I wrote my equation, what I did was I had the number of gallons would be equal to 20 minus 2.5 m. I know that I'm subtracting the 2.5 m because it's draining at a rate of 2.5 gallons per minute. So in order to answer A, I had to figure out if this was linear. We talked about in order to be linear, there has to be a constant rate of change. And they gave me that rate right here. It's 2.5 gallons per minute. Therefore, I knew that this situation would be linear because there was a constant rate of change. The next thing that it asked you to do is to find the domain of the function. Well, your domain are your possible input values. So what could we put in for m? So what I did is I figured out, well, I know that this scenario is going to start at 0 minutes and it's going to end whenever the bathtub is empty. So I had to put a 0 in for the number of gallons in the tub and solve the equation to find out how many minutes is this going to take. So when I solve that, I find out that it's going to take 8 minutes to drain the tub. So the next part of your domain is to figure out, well, is this discrete or is this continuous? Is the tub only going to drain at 0 minutes, at 1 minute, at 2 minutes, and so on and so forth? Or all the time in between? Does that make sense? So when you're dealing with time, then all those little parts of time, like decimals or a minute and a half or whatever, all of those make sense. And that's why this is continuous. Now remember, we talked about when we're writing domain and range, for continuous functions, we use inequalities. So my domain for this is 0 is less than or equal to m, which is less than or equal to 8. That's because at 0 minutes, this scenario starts. So m could be equal to 0. It's also going to end when the bathtub is empty, and that happens at 8 minutes. And then all the time in between 0 and 8 works for this scenario. Okay? All right, so the next part was to find the range. The range was a little bit easier because we know there's 20 gallons in the tub to start with, and when there's no more water, this is over. So I know my lower bound was 0, so 0 is less than or equal to g, which is less than or equal to 20, because that's how much we started with. Now for this graph, we already knew it was going to be a straight line because we identified it as linear. So I know at 0 minutes there was 20 gallons of water in the tub, and I know in 8 minutes there's 0 gallons of water in the tub. So I know that my graph slopes down, and we called that a negative slope, by the way, which was kind of getting us ready for what we're coming up with, and that would be the graph of this function. All right, if you are having any problems with this or you have any questions, please come by for tutoring. Have a great night.